Okay, as I mentioned to both of you, okay, and okay, let me introduce myself again to our student. Okay, my name Wan Ikram Wajidi. Okay, I'm from UTM, and my post is a senior lecturer here. Okay, I have been here around almost 4 years. Before this, I was in industry as a bridge engineer. Okay, so the main reason I joined UTM, actually I want to to further my study, as well as I want to share my experience outside there to our to faculty, especially because actually the the bridge dynamic subject is not really wide, especially in Malaysia. Okay.
Mhm.
And also, I was told by not I was told, I was experiencing that the this bridge and dynamic analysis in Malaysia is not quite familiar. Okay, when I because recently I noticed this difficulty when recently when I try to give some presentation about my about the dynamic test. For example, EMA and OMA, a lot of the audience, or they they quite confused uh, about this topic, and then there were many question has been raised to me about the dynamic subject. Okay, okay this problem not only for the in industry, also okay not we cannot put the blame to the our industry also, because this because the current practice follow the old practice. They do not apply widely about the dynamic analysis, especially for the bridge design. Okay, because they are thinking the dynamic analysis actually is categorized as a second order analysis. I mean the secondary analysis. It is not big important as a first order analysis, or I mean the first analysis like we doing now. Usually we design for the structure analysis. Usually we need to design for the serviceability limit, and then also the ultimate limit state analysis. But when come to the second dynamic the second order, I mean the dynamic the secondary analysis, our our designer, especially the bridge engineer, they did not really consider, and I mean they did honestly they do not interested to perform this secondary analysis, because they are thinking it is just the auxiliary checking only. So, but
Yeah.
based on my conversation, okay, from the maintenance team, especially from the JKR, and also from the like the Prolintas, Prolinta and Propel contractor. They have when they did the maintenance task for their bridge after 5 years, 5 and to 10 years, they did encounter the several anomalies. I mean the several problem take place on the bridge after 5 years. Okay, okay. This not happen only for the certain bridge, but majority, they say the common problem that they encounter, like the rubber bearing, the elastic rubber bearing was displaced from the original position, and also the expand joint big displays. I mean have some not the minor, I can say the severe damage to this part of the component. Okay, because of the one of the problem is because of the vibration on the bridge. Okay, this vibration actually when I was the one of the bridge team design, we did not really emphasize. I mean, did not really focus on how to mitigate. I mean, how to address this vibration because for example the feedback from the usually from the maintenance team, this report did not across attend to our knowledge. So when the trigger problem due to the vibration, okay, this problem usually we leave it to the maintenance to just for them to replace. But we never we fail to study what's the cause of this problem trigger. Actually, that's the problem on our team. I mean to the bridge team in Malaysia. So they did not really address. I mean prepare for the vibration mitigation. Okay. But different case for the for example, like what have been practiced in Europe and also I can say of course in the ASEAN country like the Japan and Korean. Okay, when they did the design for the subway and the high speed rail, okay, they really focus when they do the analysis for this high speed rail. Okay, for example the Shenzhen the high speed rail, they really focus how to minimize the problem due to the vibration, because they really understand when this problem we did not mitigate for them, the problem will raise eventually. So that's why
It may
from the
cause future problems lah due to vibration. Is it because of the vibration? It may cause another problem to be occur in the future for the bridge itself. Is it?
Yeah, doctor. Okay.
I think can we start now? I want Ikram to share the slide.
Can see?
Yeah.
Very clear.
Okay. Full screen.
Okay.
It will be better.
Okay. Okay, thank you, Dr. Wan Safiza and Dr. Ashari. Okay, and again, good morning and Assalamualaikum to all of you, especially to our student. Okay, please permit me to share about what you can see now on the screen. Now, okay, these are my topic for this morning. Okay, principle of vibration in bridge analysis and design. Okay, what is the today? This is the outline. I mean the introduction to this morning topic. Okay, first Okay, let me introduce to you. Let me share with you the definition. Elaborate to you the definition of the bridge vibration. Okay, next important. I mean the the importance of studying bridge vibration. Why we need to study this topic when we do the analysis for the bridge. Then next, the type of vibration in bridge. What's the cause of the vibration in the bridge? Okay, effect of the vibration. Okay, this we will look into the side effect of the vibration on the bridge structure. Then how to mitigate, I mean how to address this vibration on the bridge. Okay, first, okay, vibration, okay, as you can see, okay, refer to the oscillation or movement of the bridge structure in response to various external force or stimulate forces. Okay, it is a dynamic phenomenon that occur when the bridge is subject to force such as wind, traffic load, seismic activity, or other disturbance. Actually, there are many. Okay, as I mentioned on the screen, okay, there are few external load that cause of the bridge vibration. Okay, as I mentioned, okay, for our case, okay, we as a road user, usually the vibration on the bridge usually in our country, because we actually not really affected by the seismic region. See, the vibration on the bridge actually is due for our bridge, the bridge in Malaysia is due to the traffic highway loading. Okay, this is our concern now, because when this is become prolonged, okay, this will eventually be affected to the performance of the bridge. Okay, vibration in bridge can occur in different form, including vertical, lateral, and torsional vibration. Okay, when we run the analysis, for example, when we formulate the final element modeling, actually, we can capture this result. Okay, the mode shape associate with the corresponding vibration. The frequency. Okay. This result actually try to give impression that the vibration can happen, can induce, can come to the any direction of the bridge for the bridge system. Okay. Okay. When for our case, when we do the analysis, actually for the reference, the vertical, the first mode shape is the main concern when we do the analysis and design of the bridge, because this is the vertical analysis. The vertical vibration will give the more effect compared to the others direction frequency. The mode shape. Okay. This vibration can different frequency, amplitude, and mode vibration depending on the characteristic of the bridge and then the nature of the. Actually, this statement actually try to explain that the vibration and as well as the frequency actually of the bridge is depend on the geometry of the structure. Okay. And then also the stiffness of how we as an engineer or designer, how we want to arrange the structure, how we try to create and plan the stiffness of the overall system of the bridge. See, when we try to, okay, let's say for example, when let's say we choose one example like the wind girder bridge. Okay, we actually, when we do the design, we try to give the girder itself as the stiffer component compared to others component like the column or foundation. Because this main girder actually we try to give the stiffer because at the end of the day, this component will take more load compared to the others component, and then also this load, this component is considered directly transfer accept the loading from the vehicle and then transmit it to the substructure. That's why when we do the analysis, usually, okay, that is the common practice for the designer to focus to the main girder, to try to focus to so that we give the best performance for the overall bridge structure. Okay, that's why when we do the secondary analysis, usually we will focus on the first mode sheet, because this first mode sheet actually is the control point to the overall structure. Okay, from this first mode sheet, I mean the vertical bending actually will give the impression or give the the notification to designer the weakness or the performance of the bridge when come to the when come to the case need to resist the primary loading, especially for the traffic loading. Excessive or uncontrolled vibration can lead to accelerated fatigue. Yes, this is the common problem. But however, for the pressurized concrete bridge, we are fortunate because this pressurized concrete have the million cycle capacity to resist the fatigue loading. But however, when come to the year by years, we need also cannot deny. I mean, they cannot ignore the potential of the fatigue for the long time. Okay, and then also this the repetitive vibration also can induce the local stress for the bridge component, especially when we design for the steel bridge connection. Okay, this steel part, I mean this component part, it was categorized as the will take the high concentration shear from the apply loading. This apply loading can induce the vibration and then can give the vibration and then the severe damage to the steel bridge connection. But however, for the pressurized concrete bridge, it's not really serious when come to this the vibration. But this vibration for the pressurized concrete bridge will give effect to the other components, like as I mentioned earlier, like the rubber bearing, special joint, and also the performance of the beam itself. Because eventually this beam for example, the pressurized concrete have some the pre-camber deformation. Eventually, because the vibration can try to accelerate the deformation. I mean as you know, the pre-stress when we do the pre-stress beam, actually this pre-stress will have some pre-camber. I mean the upward deformation. Okay, this upward deformation. Okay, when we plus with the concrete, actually when the vibration we cannot we do not control the vibration. This deformation pre-camber upward elevation later will reduce the deformation, the outward elevation. Then this likely will reduce the performance towards the beam deformation, especially for the pre-camber performance to cater the vertical load. Bridge engineer or designer need to be carefully whenever to analyze and consider bridge vibration during the design and construction phases to ensure that the bridge can withstand expected forces and maintain structural stability. Okay, they employ techniques such as structural modeling. Okay, for example, as Dr. Ashari know, okay, when we do the grillage analysis, usually we use some the appropriate tool like the software, okay, to model the structure, because we want to predict and to understand the behavior and the response of the structure okay, when we apply the load. Okay, and then also from this modeling, so we can capture, and then we can comprehend the response of structure due to the frequency loading and also the acceleration of the vehicle. Okay, now we are we go to the why we need to study the vibration. First, the vibration is of great importance for several reasons. First, because of the structure integrity. Bridges are designed to carry the weight of the vehicle, pedestrian, and other loads while maintaining their structural integrity. Vibration analysis help engineers to understand and to comprehend how bridges respond to dynamic forces such as wind, earthquake, traffic loading, and other loads. By studying bridge vibration, engineer can identify the potential structural weakness. Okay, for example, okay, when we do the analysis, actually we apply the load based on the load commission that's stated in the code of practice. Okay, okay, okay. As we know, there are two limit state that we need to satisfy. First, the service limit state (SLS), and then the second limit state is ultimate limit state. Ultimate limit state we usually design up to the collapse slope. Why? For the service limit state, usually we design, we consider for the deflection and vibration. Okay, for the ultimate, usually based on my experience, okay, usually designer did not encounter the problem because this ultimate limit state is the common practice when we do the analysis. It is the basic or fundamental in the design. And come to the service limit state, okay, as I mentioned earlier, okay, our engineer usually neglect the important or the crucial of this checking. I mean the secondary checking, because they are thinking, they thought this vibration is not really called the critical for the structure, but they do not think that this vibration, okay, the dynamic effect to the bridge system eventually will weaken the performance of the bridge, such as for the displacement. Okay, for the new bridge, actually after the construction, usually the displacement is not really really important. Okay, when come to the after fire due to the creep, shrinkage, and then the temperature effect, and plus with the repetitive loading from the moving load like the vehicle traffic loading. Okay, this will induce some vibration, and then this vibration, okay, is related to the time when the bridge perform for the years. I mean after 10 years. Okay, this dynamic impact, okay, will increase, okay, with the time. Okay, for example, the frequency loading, okay, by the time the traffic volume will increase, and then straightforward, because the vibration magnitude also will increase because of the traffic volume increase with the time. Okay, that's why when we do the analysis, we need to have the traffic data to predict what's the maximum volume of the traffic will take place after certain time. I mean, after some years. Okay, because at the moment, okay, when we did the analysis, usually we based on the loading provided by the code practice, like what's the intensity on the deck. For example, based on the loaded land, for example, like which the land is the 20 meter, what's the intensity load area we need to say. But for the volume of traffic, not usually, but always in the code operative, they do not consider about the traffic volume based on the statistic data. This traffic volume, as I mentioned, will increase the vibration over the years. Okay, this vibration when they increase after the years, okay, give the fatigue damage to the structure. Safety and serviceability. Excessive vibration can compromise the safety and serviceability of bridge. Vibration can cause discomfort for the people using the bridge, affect the performance of vehicle, and even lead to the structural damage or failure. Okay, for example, in Malaysia, last for the 5 years ago, and then recently I was told by the maintenance team. Okay, now the vibration for the bridges, especially the vibration for the bridge that having the age more than 10 years. Okay, now they notice. I mean the maintenance team told me they noticed the bridge vibration become severe. Okay, for example, when they carry out the maintenance inspection, when they passage on the bridge itself, they can feel the vibration of the structure when the car is fully loaded on the span. Okay, for the simple test, usually we just put the some mineral water, okay, a bottle of the mineral water, and try to put this bottle on the top of the parapet. Then they can see the water inside the bottle is disturbed because of this vibration. Okay, they can the shaken of the mineral water can easily be seen from the naked eyes. This is actually indicate that vibration is based on the time. Okay, over the years. Okay, this will become excessive and become severe. Okay, because as we know, okay, the vibration can affect the fatigue capacity. I mean the fatigue life of the structure. Okay. This fatigue life actually, this fatigue effect can reduce the performance. I mean the capacity of the structural component. For example, the pre-stressed beam itself, they have called the pre-stress, and then they have the steel bar. Okay, this also can lead this component, the capacity become relax, become what we call in pre-stress become relaxation. They will fasten the steel relaxation of the pre-stress. And then when the steel relaxation of the pre-stress tendon become higher, okay, deal will lead to the performance. I mean the capacity of the pre-stress become reduced. That's why we need to control the vibration of the bridge. Okay, this okay, the vibration also can affect the comfortness of the road user. Okay, for example, in Malaysia last time there was a report on the MR2 road viaduct at in the Hulu Klang location area. Okay, if you know this viaduct MR2, okay, several of report has been made by the by the public. Okay, that this until now this MRT viaduct in Hulu Klang still experiencing the vibration. I mean some the shaken. Okay, especially in the jam period. Okay, the road user can feel. Okay, I myself also feel that the phenomenon. I mean the bridge vibrate is very clear. Okay. Okay, I can feel when my car stop because of the jam. Because this vibration can shaken my vehicle. Okay, design and retrofit. Okay, when it comes to the design and retrofit, especially for the bridge widening, vibration analysis play a crucial role in the design of the new bridge, because when we do the widening, okay, we play with the new and existing old bridge. Okay, for the old bridge is not problem, but when come to the origin, when come to the fresh bridge, I mean the fresh concrete, new bridge, okay, the vibration become important because this vibration can affect the concreting stage. Okay, this a new and a old bridge when we combine together by stitching the concrete. Actually, this new this vibration, the old bridge vibration can transfer this vibration to the fresh bridge. Okay, this called this slightly give the impact on the new bridge concrete performance. Okay, that's why in overseas, okay, when I study the report from the overseas, actually from the Europe country, okay, they let the new bridge before stitching. They let the new bridge before they open to the traffic. Let some time to the new bridge to setting. I mean to take place first before they combine with the old bridge. But in Malaysia we cannot do like that, especially in the Klang Valley. Usually immediately after the complete the fresh bridge, I mean the new bridge, we need to combine with the old bridge because our authority cannot compromise with the traffic jam. That's why when come to the widening, okay, actually the widening bridge is more complicated than what we when we deal with the new bridge, because when come to the widening project, okay, we need to deal with between the old and new bridge, okay, and then we need to do some kind of mitigation need to prepare some quality control, especially for the new bridge. Okay. Environmental factor. Bridges are exposed to various environmental factors that can induce vibration, such as wind, water flow, and seismic event. Okay, for this case, actually for the water flow, like for the river, when the bridges across the river, okay, we will know under the bridge actually this a column. Usually the column, okay, the pier will exposed to the river stream. Okay, this water, this current river current actually give the some called the hydraulic pressure, and then also give the dynamic look to the pier. This based on my previous experience in Kelantan last time. I was called by the contractor. This contractor told me that your bridge is vibrating, vibrate. Okay, and then on the deck we can feel this vibration because of this water flow. So can you advise me what we need to do to reduce to avoid this water flow? So then I told this contractor we cannot do anything because this water flow we cannot restrain, we cannot stop the water river. So what we can do is try to reduce by try increase the stiffness of the column. But that is the one solution. Another one, we need to confine this water this pier that subject to this water flow. So after that we did the study. We have the meeting with the project owner. That time was a JKR, was the project owner. So JKR agree we need to create the artificial island around the pier, because we want to protect the column, this column from the water river. Okay, so that by providing this artificial island, okay, we try to reduce, we try to protect this peer from the vibration problem. Understanding the interaction between this factor and bridge vibration is essential for designing resilient and sustainable bridge structure. By studying bridge vibration, engineer can develop innovative design and material that minimize the environmental impact and enhance the bridge resilience or performance. Okay, by having this vibration data, actually indirectly there are many opportunity for the manufacturer and also for the bridge engineer to explore for the others material. I mean the stiffer material than what we having now. Okay, for example, I was informed by some researcher that the vibration also can be mitigated by using the FRP, fiber reinforced carbon fiber, CFRP. Okay, that the fact I not this the fact shared by this manufacturer or and researcher. So I not confirm yet either this is the efficacy item to mitigate or not. But from my knowledge as a dynamic academic researcher, actually to confirm this we need to do the research. I mean the deep research about this. Okay, we need to do in the full scale model because what I understood about the FRP material, actually FRP material usually we use for the to increase the capacity of the crack structure, like what the JKR apply on the MRT viaduct in Kepong. But to mitigate, to reduce the vibration by using the carbon fiber reinforced material, I'm not really sure lah. What they told me. Therefore, we need to do the research. Okay, I think Dr. Ashari or Dr. Wan Sapiza can do the research about this this material that can address the vibration. Okay, the Ashari.
Inshallah, we can make a collaboration in future.
Because this is actually this a big question. Okay, in our team also because they said this carbon fiber can address this problem, but I'm not really sure because as long we do not find any the proof research. I mean the proof any finding from the field from the 3D. I mean from the lab. I cannot say it is yes or it is true to use the carbon fiber to mitigate the vibration problem in the bridge. Okay, maintenance and monitoring. Bridge vibration analysis is an important tool for bridge maintenance. Is important tool for the maintenance and monitoring program. By regularly monitoring vibration, engineer can detect any change in the bridge dynamic behavior, identify potential issue or damage, and schedule appropriate maintenance or repair. This proactive approach helps in preventing major failure, reduce downtime, and extending. Okay, in UTM actually we have the team. Okay, to like the NDT non-destruction test. Okay, this thing actually using the dynamic instrument. I mean, they instead of use the what we call the impulse hammer test, and also the using the cover meter to detect the reinforcement bar corrosion or other tests. Actually, this UTM thing actually they have the instrument by using the dynamic test, okay, to predict the vibration. I mean the structure response by measuring the frequency, mode shift, and and then convert it to the stiffness. Okay, this test can be done by comparing the control model, the control model, the undefect model, the perfect model with the defect model. Okay, by having these two results, okay, we can measure the severeness of the affected structure by comparing with the control model result. Okay, this thing led by Professor Dr. Noor Hisham Bakari and Dr. Kiman. Okay, this is the design standard. I mean the design code that are available at the moment. This has been used worldwide. Okay, for example, okay, for in our country, usually we use the for the bridge vibration. Usually we refer to BS 540, and some consultant they also opt to the latest design code, Eurocode, okay, to when they do the vibration analysis. Okay, for example, okay, there are two design parameter, the two design parameter when to satisfy the code relative. First, the acceleration, I mean the vertical acceleration. Then the second one, okay, we need to comply when we do the dynamic analysis. We need to comply also with the minimum frequency. Okay, for the BS 5400, that have been stated that the 5 Hz is the minimum frequency that designer has to comply. When you do the design, okay, I mean the planning for the bridge system, okay, make sure your minimal, the fundamental and the natural frequency of memory cannot be less than 5 Hertz, because when you have the minimum frequency 5 Hertz, actually you will satisfy all the condition, I mean all the vibration problem. Okay, for the Eurocode also follow that the BS code. Okay, they have the 5 Hertz minimum. We need to comply for the dynamic dynamic needs. Okay, like the ISO. Okay, so far there's no any frequency has been put into the for the decision, but they have introduced the acceleration to control as a guidance for the designer to follow this code. Okay, this is based on the ISO. I mean the acceleration classification. Okay, when we measure the acceleration on the side, make sure this the acceleration that we need to refer from this guideline. Okay, for example, okay, if the vibration reading from the bridge is less than 0.315 meter per second, that means your bridge is okay. But there are certain frequency that fall into this category. Then you need to be aware. Either you need to try to mitigate by installing the mechanical device like the damper or not, or maybe you need to retrofit your bridge by increasing the stiffness of your bridge, or you need to recast your bridge become stiffer than current stiffness. Also, it can be done by installing the parapet, so that overall stiffness of the bridge will increase. And then also when the stiffness of the bridge increase, that means you increase the natural frequency of the bridge. Okay, this presently bridge structure is considered as a part of strength protection system, especially in highway. The application and usage of this notable structure is undeniable in providing crucial role to road or highway element in design, mainly where the complexity of highway design that is demanding of the two solver for the case of the multiple element. Okay, nowadays, okay, we see many of the road network in Malaysia, especially, okay, they are busy to construct the flyover, I mean the elevated highway, because actually, especially in the Klang Valley, they do not have the luxury of the land to construct the road bridge, to construct the road, okay, on the at-grade, sub-grade. So to mitigate the lack of the land for the new road, so they have to go to the alternative way by providing the flying road. Okay, to support this flying road, they have to construct the elevated bridge. I mean the elevated highway. Okay, so you as a student need to prepare yourself when the government or project owner asks you to provide some structure to support this flying road. This is the MRT. This one of the okay, you can see the picture. This is MRT. Okay, in front of the Flamingo in Ampang. Okay, this that I told just now. The second bridge, the second viaduct. Okay, you see from this from the pier to pier. Okay, the effective length is the almost 40 meter, about 39 point something. Okay, this bridge you can see the arrangement of the being very close actually. Okay, the arrangement already when we from our eyes we don't expect the bridge will experience the vibration because the bridge is look like this. The bridge is very stiff. You know, a lot of the a number of the beam has been put on the pier to support the traffic loading. But this bridge was experiencing some the very clear shaken. You know, I also can feel the shaking of the bridge, especially when the heavy truck pass by this bridge. So you can see that's why I believe the designer for the bridge also they did not anticipate the bridge will experience some vibration. Okay, because the arrangement of the beam and then the beam itself also quite deep beam, and then also the beam side by side. I mean the beam spacing is less than 2 meter, but because of the lack of knowledge of because of the ignorance of the secondary analysis, okay, they forgot to run they ignore. I mean they reluctant to run the secondary analysis, and then now this bridge experience some the distortion. I mean the shaken scenario when the road user pass by this road. You can feel it. Okay. Last time I visit this bridge and I try to snap some picture. Okay, try to study what's the cause of this problem. I mean the excessive vibration, because looking at the beam quite deep, and then also the arrangement of the beam quite luxury. I can say not really far from the one-to-one beam is quite close. I mean the distance, so still having the vibration. So that's why when as the engineer, we cannot simply assume that your beam this bridge is one shaken. Okay, because that's why when we do the design, we cannot only satisfy the first order analysis. I mean the ultimate or surface limit. We also need to check for the secondary analysis. I mean the dynamic impact for the long time. Okay. According to the previous inspection report that has been done by JKR Forensic team, okay, that time led by Dr. Lim Ka Ching. Okay. Okay. Actually, there are many bridges are affected by the vibration, but the clearly has been reported by the public. I mean by the client to for the forensic thing is Sungai Muar Bridge, Golok Bridge in Kelantan, Jalan Kinabalu Bridge. This is the old bridge. Okay, after 20 years, okay, this will experience some excessive vibration. These affected bridges are still being monitored by public work department in terms of the structures or not. Okay, usually we monitor in terms of the cracking and then also the deflection lah usually. In current practice, engineer design their bridge according to relevant code of practice. example, like as we know, in Malaysia we always follow the BS 5400 Eurocode EC2 for the concrete, ACI. Okay, sometimes for the box girder, usually we also use the other than the BSN Eurocode. We use the supplementary document coming from the American code, and some relevant technical document like the term of reference BD 3701 and JKR term of reference. They design their bridge with respect to design loading, partial, material defect, allowable stress material, and other design, but they do not pay attention on the fatigue and vibration problem. This I can say this very clear. Okay, from this cooperative, they do not pay attention. They do not really focus on the secondary dynamic checking. These cooperatives are mainly focusing on structure member design capacity, as I mentioned just now. Okay, they really focus on the first stage analysis design, moment capacity for the ultimate checking, shear capacity, allowable deflection for the SLS, and torsional capacity. In other words, it has only been emphasizing on the first principle order. However, not many of them has concern on the issue of the bridge dynamic vehicle. Moreover, this problem has led to structure in expression both force and natural vibration phenomena, especially as a result of daily traffic loading pattern from moderate to severe loading after some time. Unfortunately, this issue has not been looked into seriously by our designers, since it may cause adverse effect and detrimental to structure health, as well as our overall performance of the operation in the long run, like the fatigue loading. And the vibration also can affect to the structure life, as well as the material involvement, like the bearing, especially joint, and then also the structural component, I mean the beam itself. Okay, this is the one example of the project in Johor Bahru. Okay, actually this not really new. Okay, 10 years, the age about the 10 years after opening. Okay, I was told by the JKR team. Okay, this which has been retrofit. I mean, has been rectified because there was some crack has take place on the soffit of the beam. Okay, this beam very slim, and then the span very long. Okay, so they use the previously the designer used the secondary beam to control the deflection, and I anticipate that they use the secondary beam to control the load distribution among the main girder. So this methodology, this way actually not really good to control, because I know their limitation. Actually, they want to control the depth of the beam, because they have the very limited clearance from the root to the soffit beam. They cannot achieve in 5.4 minimum clearance. But that's why they go for the slim bridge. I mean the slim structure. Then they put the transverse member to enhance the capacity of this slim main beam. But the vibration still but by adopting this way, they thought the vibration can reduce. But actually, based on the complaint from the public, okay, and then also got the spalling on the beam previous last time. Okay, the beam cannot take this method of the construction. Nowadays, I heard they do some grouting to seal some cracking on the soffit of the beam.
Okay, I can interrupt for a while. Okay,
okay,
so because I'm have a wonder about this. You have mentioned that the girder is slim, isn't it?
Yeah, slim.
Okay, so maybe it can trigger the buckling of a beam. girder, isn't it? So that's why they
buckling.
the intermediate diaphragm to improve the stiffness of the bridge. So in
Yeah.
other words, it will increase the natural frequency of the bridge, but that not to work. Am I right?
Not work. Yeah, not really work.
So the issue is the buckling of the girder, isn't it? Because
yeah, buckling due to the eccentricity of the load. When the vehicle loading is situated in between of the beam, actually the buckling will clear to see. Okay.
So
But the problem is I want to address here because due to the limitation of the clearance height, they went to the beam depth reduction. Okay, and then by having the less beam depth, okay, they try to introduce the intermediate diaphragm. I mean the secondary beam. Okay, but this way actually not really successful. Because the vibration from our reading last time is quite high, more than what the code has limit. Okay. And then also as you know, the frequency of the beam sled actually in Malaysia, especially for the beam sled like this, cannot attain 5 hertz minimum. That what has been stipulated in the code of practice. Okay. Now JICA is a monitoring of this bridge situated in the Kangkapulai, Johor Bahru. Okay, bridge design correction. Okay, as I mentioned earlier, okay, vibration. Okay, we need to know the impact of vibration on the bridge design. Okay, material selection. Okay, as I said, okay, the vibration for the concrete element is lesser than steel element. Okay, for the railway steel bridge, okay, the vibration is more than concrete bridge railway. Then structural modification. Okay, this structural modification. Okay, when we do the analysis, actually, okay, it is quite important, crucial for the designer to perform the secondary analysis. Okay, by having the second analysis result, okay, I mean the dynamic analysis. Okay, we can know either this structure can perform okay or not after we open to the traffic. Okay, when we check for the first order analysis, like the ultimate limit state, sure, designer will be happy because all the requirements are passed. But when come to the secondary, we cannot say this. You as a designer cannot so be so confident to say that your bridge is satisfied all the conditions. But you have to until you satisfy the secondary checking first. Okay, based on my experience when I did the secondary checking for the past bridges, I mean did by the other consultant. Okay, because I was invited by the JKR last time, LLM, to perform the checking. Okay, majority of the bridge in Malaysia, when we did the structure, I mean the dynamic checking, cannot satisfy what the requirement has stated in the code of practice. Even for the fundamental frequency, I mean what I told 5 hertz, that's stated in the BS also, the beam sled bridge also cannot comply. Okay, now there is a trend now that the designer obsessed to produce the very slim structure, like what they are doing now. They try to go to the high performance concrete, okay, by having the very slim, very thin structure. But this manufacturer last time approached me to introduce to showcase their product. And then I asked one thing to them, okay, how about the dynamic analysis? How have you performed that? How about the vibration? Okay, when considering the time effect like the creep especially, and then also the vibration, the dynamic for the flexion for the long term after 10 years. Have you considered that? They cannot answer when I ask that question to them, because what they are really focusing now, they want to promote their business and to promote their innovative product. Okay. Okay, cause of vibration. Okay, as you know, okay, then the vibration can come to the from vehicle traffic loading. Okay, from the wing load, but in our country, this load is not really critical because our country not situated in a typhoon. I mean the cyclone area like the others country like Philippines. Okay, and that's so vibration with the president. This is a very small impact to the concrete bridge. Okay, due to the pedestrian activities. Okay, because for the road bridge, okay, they have the capacity to overcome this pedestrian load. But nowadays, year by years, the traffic volume will increase. As you know, the heavy vehicle increase also as the normal vehicle, and then this by this increment will also lead to the higher vibration to the bridge. Type of the bridge, okay. As I mentioned just now, so the vibration also can come from the seismic. But for our region, actually we are close to the Indonesian, as well the Pacific region, for the seismic activity. Okay, we just have the tremors, the small vibration. Okay, from my colleague, Dr. Zamri, from the earthquake center. He said the earthquake effect from our neighbor country like the Philippines and also the Indonesia, okay, give the more effect to the Sabah area on Borneo region only, but the peninsula is not really high. Okay, when we do the vibration control in the design, especially for the seismic, usually we use 3%. Okay, 3% of the live load loading, and then apply static as a static horizontal on the structure. Okay, but when we use the JKR document, okay, usually JKR want to use the slightly higher than what we applied previously from the practice by the Australia country. Okay, for the JKR, usually they use a bit higher. Okay, they use 20% live load plus with the dead load, and then apply horizontally to the restructure. Okay, but most of the stakeholder, I mean the project owner, do not agree to use this JKR approach. I mean the methodology to apply, because when use the 20% of the live load plus superimpose dead load, the load for the seismic action actually will also increase the cost of the project more than 30%. I was told by my friend. Okay, okay, for the MRT currently, usually they use the 3%, what I mentioned just now. Okay, because like the Prasaranas, they want to incur the higher cost for their project. Okay, the resonant vibration. Okay, resonant vibration. Okay, as I said, actually, what I mentioned just now, that your project Kinabalu Bridge, the MRT, actually we can say it is the vibration, resonant vibration, but it is categorized as the small resonant, not like the Tacoma Bridge resonant. Okay, that one we can see as a small or minor resonant to the bridge, because we can feel. Okay, when we stand up on the bridge, we can feel the vibration, and it is called the minor resonant. Okay, wait. This is a cable vibration. Cable vibration usually for the, for example, for the cable stay bridge. Okay, usually the vibration, okay, will take place when the car, the traffic car, the car is moving on the bridge. Sometimes this cable vibration also can move because of the wind load. Okay. If you go to the Putrajaya, you can go to the signature bridge like the Wawasan Bridge, or you go to the Precinct 8. Okay, you can see the cable stay bridge. Okay, okay. When we have when we stand away from that bridge, somehow we can see the movement of the cable when there are few car has a pass by on that bridge. That one is we cannot. I can see. I want to highlight here. We cannot stop the vibration. This is the norm. I mean this is the natural, the physics, the fundamental. But we can control. We cannot eliminate at all the vibration, this phenomenon of vibration, but we can control under certain that imposed by the cooperative. But I can say we cannot stop. We cannot eliminate at all. Yes, Dr. Ashari, any question?
Okay, proceed. I'm going to asking a question at the end of the session.
Yeah. I expect you.
So
you always.
You have around 20 to 30 minutes. Okay.
Okay, I request. I need at least 2 hours.
Wait.
Extra 2 hours can. I have 100 pages.
Okay.
Okay. I just joking lah, Dr. Ashari.
Okay.
Okay. Number 6. Bridge can experience vibration due to structural form, such as I mentioned just now. I show to you the example of one of the bridges in Johor Bahru. Okay. The slim bridge. Okay. I know this limitation of the designer at that time because of the clearance height. Okay. They cannot go to the larger. I mean the deeper beam depth. So that's why they have no choice. They go to the slim. I know when. Okay. Last time I also encounter this problem. Okay. I cannot increase my beam depth. But if we have the proactive attitude as a designer, we need to usually when I face this problem, usually I try to go to something that called the extraordinary solution. Okay, we go to the basic, the fundamental way to solve the problem. Okay, usually when I encounter because of the clearance height is not sufficient, then you try to push the limit. As a structure engineer, you try to compromise with the structure capacity. You try to reduce the beam depth. That's mean you reduce the beam stiffness. The glisten. When you compromise with the stiffness, that means you tolerate some of the capacity towards the vibration problem. You reduce the stiffness, that will give effect to the other problem, will cause to other problem eventually. Okay. By right. Okay. If you, in his shows, usually based on my previous experience, usually I try to consult with the alignment engineer. The highway engineer. Try to elevate their profile element, which the alignment. Okay, so that we can provide the sufficient beam depth. The optimum beam depth. Because last time when I deal with the JKR, usually I did JKR, then the consultant highway engineer. I try before they start do the design. First thing I study from what they given to me about the alignment. I try to check what is the span, the span length. The span, the typical span that I can put the column, and then also I also need. I will give to this highway engineer what's the minimum beam depth to them, so that when they do the alignment proposal, they can consider our limitation. The beam depth 40 meter usually. Okay, I want they use 2.1 meter. 2.1 meter only the beam depth, not plus with the concrete slab plus the premise. The pavement. So that we as engineer, we need to clear this thing to the heavy engineer. Tell them that I want you design by considering our structure dimension. Okay, your element must pass this requirement, and then also you need to leave 5.4 meter the clearance height after after considering the beam depth from the soffit beam. Okay. It is important to note that excessive vibration can lead to structural fatigue, accelerated wear and tear. Okay, this one I agree because we have for example, we have the rubber bearing underneath of the beam. Okay, this is actually the rubber bearing. We use the normal damping rubber bearing. Usually, when last time from my experience when we did the inspection, usually somehow we can detect the rubber bearing also melting. Apa ni? Cair. But because of the wear and tear process. Okay, because of the vibration itself very high on the beam vibration very high, and also the traffic volume is considered very high, like for the Puchong area. Okay, last time we went the inspection under the bridge. We noticed that the rubber bearing, not one but more than one, I mean 3 or 4 pieces of the rubber bearing were experiencing the melting because of the expansion shear and expansion problem, also because of the vibration as well. Therefore, monitoring and analyzing bridge vibration are crucial for ensuring their safety and longevity. Okay. Okay. Vibration can have effect leading to various components and potentially compromise the structure. Here are some of the common adverse effects of the vibration. Fatigue failure. Okay, as I mentioned, the repeated vibration can induce fatigue stress in bridge component, especially for the steel bridge at the welded connection and high stress region. Okay, this happens both concrete and steel. Over the time, this can lead to crack and fracture. Okay, these are the crack actually we happen for the steel bridge lah. For the KTM bridge last time when I went for the site inspection. Okay, we noticed the steel bridge has a deflect very obviously, and then we check and then we detect some structural crack, not the minor crack, the structure crack at the midspan due to the excessive loading is one thing, and the excessive vibration. Resonance, okay. As I said, resonance also is the frequency. Actually, resonance happen when the frequency of the loading is meshed or over the fundamental frequency of the bridge, I mean of the structure, and resonance will take place. Resonance amplifies the vibration, causing excessive motion and potential damage to the bridge, of course. This phenomenon is particularly dangerous and can lead to catastrophic failure if we do not overcome this. Okay, this is the example. Okay, this is the LDP Puchong Bridge, near to the cable stay bridge, Motorola Bridge. Okay, this one there is the concrete bridge. Okay, when we did the inspection, we detect some called the walk-in bridge, because when we do the study, because this walk-in bridge happened due to the excessive vibration. You see, the vibration. Okay, actually the way we put the bearing under the bridge actually just free sliding only based on the friction. There's no any stopper, and there's no any dowel bar to pin this bridge. I mean to stop the bridge. Actually nowadays they have provide some the key. Okay, key to stop to prevent this bridge displaced like this. Okay, so when this actually I want to mention here the vibration here very high. Okay, and then also when see the traffic, also the traffic volume quite height lah that time, especially at the peak hour. And then because of the excessive vibration, this bearing has a displaced from the original location. Okay, this is the screenshot from the I got this from the Malaysia Kini. Okay, then also I have the detailed report, the forensic report from JKR about it, but I cannot share here. But since this is the is can be shared and was published in the public through the news lines. Okay, I share. Okay, this is based on from the report. Okay, Dr. Ernst King. Okay, from his report. Okay, Sungai Muar Bridge, Sungai Golok Bridge, bridge at Jalan Kinabalu. Actually, there are more than this. Actually, okay, based on from my conversation with the JKR team. Okay, they said now there are many number of the bridge has been reported expressing the bridges after 10 years. Okay. Such a deterioration. Okay, vibration can accelerate the deterioration of bridge materials such as piling, okay, for the concrete, and then also like this vibration also can for the steel, then can loosen the bolt nut. I mean the connection. Okay, if you have the for the LRT, okay, we have the rail, and then we clamp it by using the bolt and nut connection. Okay, if the vibration, if we do not install the tube mesh damper, TMD mechanical device, I mean the absorber to reduce the vibration. Okay, I believe this vibration that trigger from the LRT load, this cause will loosen. I mean the bolt and nut connection will lose very fast. Okay, that's why they install the damper at the rail, at the track, to control the vibration, so that their maintenance can be the maintenance time, I mean period, can be longer, can be extended from the usual. Comfort and safety concern. High intensity vibration can affect the comfort and safety of the bridge user, particularly for the pedestrian and driver. Excessive vibration can cause discomfort. Okay, as I said earlier, okay, when you drive your vehicle and then pass by over the MR2, but you stop and then you start at the roadside, and then you can try to feel, and you can feel, not try to feel, you can feel the excessive vibration that happening right now. Still that bridge still vibrate until now. There's no any action. I mean, there's no any retrofitting stage has been conducted. Okay, vibration can also affect the functionality of the bridge system, including electrical, also including like the feeder, electric feeder. Okay, mechanical and hydraulic component. Vibration. Okay, for example, okay, the vibration also. Okay, you see that the rainwater downpipe also can lose their part because of the vibration. Okay, that's why for the rainwater by downpipe, okay, when we have the bridge, okay, usually we need to install the pipe to discharge the rainwater from the deck. Okay, this the water this piping actually always displaced from the location because of the vibration. Nowadays, the manufacturer have provide some the rubber, okay, to reduce the vibration. I mean to minimize the impact from the vibration of the bridge to this rainwater downpipe. Okay. They have introduce some like the damper, the small rubber, and then to put together, and then try to put some rubber bearing at the support of the rainwater down pipe that attached to the bridge parapet, under the parapet. Vibration also can disrupt wiring for electrical, impair the sensor, and affect the operation of the bridge. This one for the structural health monitoring system. Okay, usually they have they will like the second pinner bridge. They have they put some equipment like the accelerometer or sensor on the bridge. Okay, because they want to, and they put the strain gauge, then the other mechanical device to monitor the performance of the bridge daily monitoring. Okay, they want to collect they have to record the information, especially for the bridge performance, including the vibration. Then they will analyze for the future analysis. Okay. This issue can impact the overall functionality and the maintenance of the bridge. Therefore, to mitigate the adverse effect of the vibration on the bridge, engineers employ various strategies, including structural modification. Okay, some engineer. Okay, for example, what I found, they usually try to increase the thickness of the slab. Okay, one of the way they want to increase the depth, increase the stiffness of the bridge. Okay, they try to top up another layer on the top of slab. Okay, but this one involved with the we affect to the road profile. Okay, usually they need to get the approval from the project owner first, because this modification actually will also affect to the highway design. Okay, I mean the level of the highway, so will affected because of this such communication. Okay, dampening system. This is the common way. Okay, can we use, usually we need to have we provide the mechanical device like the damper, tune mesh damper TMD, and also the liquid damper. Okay, we usually we install, we attach this under the beam and then attach to the fixed point. I mean the very stiff foundation. Okay, to control the vibration of the beam. Okay, this damper actually usually we also employ for the cable stay bridge. Usually we put at the connection at the anchorage of the cable stay. And also to mitigate this, we also run the regular inspection to detect and address potential problem. Designing bridges with appropriate damping technique, considering vibration source during construction and implementing maintenance plan, can help minimize the risk associated with vibration. Okay, that's why when we try to avoid this problem, actually we need to start from the first step of the design. Okay, engineer need to when, in other words, when we want to do the design analysis, make sure the selection of the material and then the selection of the geometry of the structure, I mean the system overall of structure, we need to consider carefully. Cannot simply just copy and paste from the previous project. Okay, I want to make sure we have to go to the previous site, I mean the existing site, to discuss with the maintenance team to get the feedback about the performance of the existing bridge, so that we can improve in future when we do the design, that we won't repeating the same mistake that we done for the previous project. Okay, understand, Dr. Ashari?
Yeah, understand. It's clear.
Okay. Any questions so far from Flo?
Maybe we can make it at the end of the session, but then.
Okay, you can interrupt with me. Okay, I have no problem, because I open to discuss. Okay, how to control or mitigate the bridge vibration? Usually, we controlling or mitigating bridge vibration typically involve a combination of this acceleration. As I mentioned, usually we increase the stiffness. Okay, and maybe we introduce another secondary member, like what designer just now introduced. Use the secondary beam. Okay, install transversely. Here are some strategies that can help control or mitigate vibration. Okay, conduct thorough, detailed dynamic analysis during the design phase. This is the first step we need to do. Okay, when we involve with the design planning. Okay, we need to study the material that we use. Okay, for example, the concrete grade, not only respecting of the durability, what we also need to, because each grade give the different vibration response. Okay, we need also to study about this. Okay, choose for the appropriate type and combination and the minimal. Okay, for example, nowadays they are assumption, they are mythos, I can say. They might by the designer, by using the box girder, actually box girder can reduce the vibration is lower than pin slide. Actually, that's not true, because based on the journal that I read just now, actually multi-set, for example, this is the example. Okay, the mic that is not we cannot use. Okay, actually multicellular beam, U-beam also, when we provide with the sufficient number, also can have the lesser vibration reading than the box girder. That's the one thing. This happened in the LRT project, LRT3 project that is currently construction. Okay, they are in opinion that by using the single box girder, single U-trough span 20 meter, the vibration is lesser than the common U-beam. Actually, when my colleague Dr. Hisham, when he did the dynamic test, really, okay, their team found that the vibration for the single span box girder is higher than multi-cell U-beam. Whatever you want to, whatever the fact that you receive from the any informer that saying that the single cell box girder is higher, you have to carefully carefully accept it. You cannot simply accept this the belief. Because based on our finding previously, when we conduct the dynamic test or EMA, experimental model analysis, we found that the box girder vibration is higher than multicellular U-beam. Because actually this you know, the box girder, for your information, the box girder cost is higher than multicellular beam, because why? Because the formwork and then the technology to construct the single cell box is much higher, much expensive than multicellular U-beam. That's why the box girder cost is higher, but they do not really give the very good performance towards the vibration. And then okay, incorporate suitable material with good damping properties to reduce. Okay, the damping of the material usually we can get, okay, by, there are two ways. Either we can calculate numerically, theoretically, or we can measure from the side. The best way is we try to get this result from by dynamic test, and then from the dynamic test we can calibrate our modeling, our calculation, improve our calculation by using the actual result from the site. Consider the effect of the wind, traffic loads, and environmental condition during design. Okay, structure modification. Okay, as I mentioned just now, okay, it is involved by modifying of the stiffness of the structure of the main member. Then, okay, also I want to mention here also the boundary condition or support condition also can play the role of the vibration. Okay, okay. For example, okay, usually when I involved with the Suka project, okay, the Sungai Bersih Ulu Kelang project, there were two approach design has been introduced to me, because last time I was the lead consultant for this consultant. So there were two proposals from the different consultant. First, they come with the continuous bridge. I mean the integral bridge. Okay, another one is the common approach. I mean they use the rubber bearing. I mean simply support but multi-span. Okay. Then when I asked this designer, this first engineer, okay, why you opt for the monolithic? Okay, what this friend answer to me. First, they want to reduce the maintenance. They want to omit the usage of the rubber bearing. And then the second thing, he said to me, he want to reduce the vibration. Okay, so that's why. And then also another one is they want to go to the slimmer structure by having this continuous and monolithic structure. Actually, the span moment can be shared, can be transferred to the other component like the substructure, like the beam, like the pier. So then I asked him to submit the detailed calculation to me, and then I also run my analysis lah to prove what he said. Okay, then I compare my analysis and his analysis, and then what he said to me that his reason to me why he opt for the continuous beam instead of the simple support is true. So here I want to share, actually the boundary also play the role to mitigate the vibration, because from the there is the journal also study address about this difference between the continuous and cerebral support. Actually the continuous structure can reduce the vibration of the bridge. Okay.
And can I interrupt?
Okay, can, Doctor.
Okay, for the continuous bridge, or in other words, sometimes we call it integral bridge. So how this particular bridge absorb the vibration? Because if we not really taken care on this effect of a vibration on the integral bridge, so maybe some crack will appear, and especially on the support. Okay, in the support of bridge. So how they cope with this problem in the design?
Okay, usually this is about the moment sharing. I mean the forces sharing. Okay, from the superstructure. Okay, they transfer the loading by the flexibility. Okay, okay, we know our bridge will experience some the daily cycle like the expand and then the shrink due to the first because of the weather. I mean the hot and dry, hot and cold by the weather, and then also the primary load also. These are load that generated from the span from the beam. Okay, will transfer to the pier, and then this pier also will transfer the load to the pi group. Okay, this actually this flexibility. Okay, when we have the flexibility movement. Okay, usually when come to the integral. Okay, they try to go to the flexible structure because they want to control the stresses, the internal stresses due to this the given load. So that's why when they do the integral design, usually they want to we want to go for the flexibility of the structure by having some very slim structure, not very slim, very optimum structure, which respecting of the deformation, the limit of the deflection. That how they control the stresses of the structure, and then also the vibration.
Okay.
Okay, Dr. Syahri.
Yeah, I got it.
Because let me share with my my cases in the PhD research. Okay, when I do the modeling final element analysis by using the abacus, we model exactly follow the existing structure. Okay, there are two span. Okay, but simply support. So we follow exactly. Then when we notice our vibration, our frequency, and the acceleration when we use the heavy truck 24 ton is considered quite high. And then we have run another case, okay, to mitigate this problem, okay, by having the continuous structure. Let's say we modified this structure, okay, by modified the boundary condition, the support condition. Instead of the similar support, we go to the continuous structure, but still have the bearing, but we just continuous. But we just combine the adjacent span only to span. Then,
so meaning that the rubber bearing is still there.
Yeah, but in line, just single only, single line only. Instead of the two line at the intermediate, we just propose just one line only, very, and then we found that the vibration, I mean the acceleration vibration reduced tremendously when we go to the continuous span. Okay. Okay, structure modification, reinforce the bridge structure in a critical area to increase the stiffness and reduce flexibility. Okay, this is about section. Not only we top up the section, I mean the concrete of the bridge. Okay, there's the research. Okay, I found that the arrangement of the steel also give the effect to the response of the bridge. Okay, in this conduct by the researcher, okay, from the China, okay, he found that why based on the different arrangement of the reinforcement, passive reinforcement bar, okay, they found the response of the structure also different according to how we arrange how the way we arrange the reinforcement. Either we put the parallel to the beam or to diagonal, also give the effect to the response of the structure. And then also the way we lay the cable, we design the cable profile, the pre-stress also give different in terms of the acceleration reading. Okay, let's say we compare, we use the straight cable, and then another case we go to the parabolic cable, also give a different in terms of the structure response. Okay, the damping technique is the common way now. For example, the LRT. Okay, and then for the slim and slender structure, we use tube mesh damper to absorb the vibration. Okay, which this tube mesh damper usually we have the custom the liquid or sometimes we use the oil lubricant oil to as a hydraulic principle to take the dissipation energy from the working structure. Utilize passive damper such as viscous damper, friction damper. Okay. Yeah, usually for the tube mesh damper, usually we use together. We use along with the accelerometer. I mean the accelerometer. Because we want to monitor and then to study the vibration reading. Then because let's say because this vibration actually wave actually we can also detect some damage of the structure. Okay, because based on the dynamic test, okay, we can foresee the behavior of the structure if the structure have some local damage on their members structure. Okay. Usually, okay, from there we can detect that there is the slightly anomalies on the reading for the vibration. Then we can know either this stiffness is okay or insufficient. When and then also we can measure the severeness of the damage on the structure. Okay, regularly. Okay, another one is to mitigate the vibration is regularly inspect the bridge. This is the common way by go by physical, observe that one. Okay, this is has been practiced by the JKR and also by the LLM. Implement an ongoing monitoring system to detect another bridge vibration. This can include sensor, okay, sensor like the strain gauge, accelerometer that I'm using now, PCB, piezoelectric accelerometer, and then also inclinometer also have been installed on the site, okay, to check the structure deformation. Okay, this one is aerodynamic modification is okay for the bridge. For example, okay, for our case, for the beam sled, usually we can play around with the corner beam. I mean the H beam by having some the friendly aerodynamic to cater for the dynamic for the wind direction, wind forces. Okay, usually when we start doing this, okay, usually we need to study the direction of the wind flow. Okay, when let's say the wind flow direction is significantly effect to the give the impact to our bridge. Usually we try to modify the outer girder, outer beam. Okay, let's say the left or right, the most left hand side, and then we try. Usually we go to the instead of the T beam or this beam only, this beam, the corner beam, the H beam only, we use the U beam, and then the inner beam we go back to the T beam. This have been practiced for the first spinner bridge, the widen part of the bridge. We have used the different stiffness of the beam. The outer beam we use the U beam. The inner beam we use the T beam with the same depth, because we want to cater for the aerodynamic due to the wind load. Okay, in summary, this the way we control the vibration by using the mechanical device, passive control measure, active control measure. All these devices are damper. Okay, and then modification of vibration. This is the fundamental of the vibration control. We modified the bridge geometry. I mean the bridge stiffness. It's important to note that the specific approach to controlling vibration depend on the factors such as bridge design, material, okay, material, location, and intended. Oh, sorry, I cannot see this. Okay. And consulting with structure engineer expert in bridge dynamics is recommended for a comprehensive assessment and tailored. Okay. Actually, Malaysia, the practice to consult with the dynamic is I can say is rare lah. It's a bit rare because our location, the bridge, in Malaysia, we do not have the heavy wind load like the typhoon, like the Filipina. So this exercise is not really applicable in Malaysia. Okay, so but when come to the dynamic effect by the traffic load itself, and then also from the seismic, I as a bridge engineer, I think nowadays this is the time all the bridge engineers especially, we need to consider. This time we have to consider because by the time the seismic intensity will increase. Okay, because the seismic fall is approaching to our Malaysia, our country, continental. Okay, especially from the Sumatra. So we have to later in future. Nowadays, I think we have to consider the seismic intensity to the bridge design, and not only for the bridge, not only from the traffic loading, but by the years the traffic volume will increase by the time. So we have to also need to consider as an engineer. We have to consider. I'm not saying we have to go for the over design bridge, but we have to think how to what the way to improve and to prepare our structure to face this problem later on. Okay, this vibration analysis method. Okay, for the vibration analysis method, we use the model analysis. Actually, the model analysis come from the model test. Okay, from the operation model analysis, and also from the empirical model analysis. Or the model analysis, actually the process how we process the data. Okay, the data consists of the transfer function, and then the domain and the frequency domain decomposed from the this dynamic test. And then our role, we have to try to decompose. I mean, try to simplify this data that we capture from the site, so that we can transfer it to the readable data result. Okay, that we call the model analysis. We process the site data and then transfer it to the readable report. Okay, there are several ways how to process the data. Okay, usually we use the curve fitting method. Okay, we convert the transfer function data from the site to the model property. I mean, we convert it to the frequency, natural frequency, damping, and vertical. The acceleration. Okay. Because there are three model data usually to be used by the structure engineer. First, natural frequency, damping value, and mode shape, and four, and then acceleration. Okay, there are four. Okay, mode shape also we need to process. We need to use the model analysis so that we can create the displacement. I mean the mode shape for the each frequency. From the mode shape, we can understand the dynamic response of the structure when subject to the external load. Okay, frequency-based method. Okay, this one can be performed by using the model test. I mean the dynamic test, time domain. Yeah, actually time domain from the site data. Then we need to convert it to a frequency-based method. And then final analysis, we can use the appropriate software for the research. I'm using now the Abacus, because our university have the license for the Abacus only, not ANSYS. ANSYS also can be used. Okay, but for the research in UTM, they want our team, our researchers team use the Abacus to conduct the dynamic modeling.
Okay, I can interrupt? Because we are running off our time. Can you sum up your presentation, because we will move to the Q&A?
Yeah, very fast.
Yeah, because we spent on 2 hours, so actually the time. Okay.
Okay.
The rest make it another session, maybe. Okay.
Okay, I think we. Okay. Okay. There are two types of the vibration test. As I mentioned, these are two major tests in the dynamic. First, operation model analysis, and then second one is experimental model analysis. The outcome of result is the same. First, we at the end of the test for this both testing the frequency of the structure, damping, mode shape, and acceleration. But what are the difference between these two? Actually, the exciter or the simulator in order to exciting the bridge to get the response. Okay, for the OMA, usually we use the artificial exciter, like the called the traffic loading like the car or truck. And then also for the experimental, we use the empirical, the lab exciter. Example, for this case, we use the hammer, model hammer, okay, to exciting the structure in order to get the response. Okay, this is the procedure to set up the vibration test. Okay, I want to summarize my presentation. Actually, okay, as a structure engineer, it is important for the designer or structure analyzer to understand the response of the structure when we impose the load. Okay, as a student or as an engineer, we know when we give the unit load, okay, the deflection we can calculate directly based on the force displacement method or Macaulay method. Okay, there is a slope deflection method. But to estimate the response of the structure, we are not really understand. As a structure engineer, I can say I'm not really good in the dynamic analysis. But I still learning. I try to understand. Okay, I can say I in exploring how to understand the structure according to the dynamic viewer. Okay, because dynamic subject is very important because the structure the dynamic behavior of structure we cannot get the response immediately after your structure is served for the service. Actually, it is time dependent. Okay, for example, my structure last time. Okay, after 10 years, who anticipate the structure can vibrate? Okay, first fire we cannot detect. The maintenance team cannot detect my vibration, my structure vibrate. But now after 10 years, I got the same team report to me. Ikram, your structure is vibrating. I don't know how it vibrate, and then it is quite shock to me, because what the scare for the designer is I can when we get the distress call from the site team that structure is cracked or failure. That's a very scare information to every engineer or designer like me also. I also scared. But this person this thing call me the structure vibrate. When I receive this information, I instantly went to the site and then measure the structure, ask the forensic team to measure, ask the client to get the information from the forensic team by measuring the vibrate structure, the shaken structure. And then luckily my structure still intact and then can be used, no crack detected. But as I mentioned, the comfortness, the level of public worry, you cannot silent. They will make noise and jumping that the structure is not safe. How to address how to close their mouth? Their complaint. We have to rectify this problem. How we have to address this vibration problem. Okay, that's why I want to tell here that before we start to design, we have to do the preventive action. Okay, that's a mistake lah. From my personal mistake, because we were not thinking the dynamic problem before when we do the design. We just focusing on the first order analysis, but we ignoring the dynamic the second order analysis. The dynamic checking. Okay, that's all from me.
Okay.
Very short time.
Maybe next time we could make 3 hours.
3 hours, make it 3 hours. Make it longer.
Really not fair to me. Really not fair for me. It's okay lah.
Okay, it's a good information. Very informative. Okay, Dr. Wan, can you continue with the Q&A?
I mean, thank you, Arwah Ikram lah, for a very impressive sharing. Okay, and and hopefully lah, all the students can get the clear pictures lah, actually, on how vibration actually contribute an important role in bridge design line. I think I would like to open to the floors for any questions. Student, you can raise your hand if you would like to ask a questions, or you can write on the chat room as well to ask anyone.
Okay, guys, don't shy. You can ask me anything. Don't worry, you are student. I always told my student in the class, don't shy. If you want to study, don't shy to ask the stupid question. I willing to answer. Because you are still in ignorance, don't worry. We are student. So often need to study. Okay, anyone volunteer? Ask.
Any question? Oh, so the floor is silent. Okay,
you can ask me any question you want to ask.
Okay, since there is no student asking a question, so I have a quick question.
Yeah. Okay.
I do have question.
Can you introduce yourself? Which group you come from?
Your name yourself, please.
My name is Siti Zulaika, from group A1 from UiTM Patang Pau.
Group E1. A1.
Yeah.
Okay.
Fatin Alifah.
I have question. Saya share device dengan Fatin tadi. Internet saya lambat.
Okay. Okay.
Contohlah, kalau dekat Penang ni ada tsunami.
Okay, betul.
So macam kita kena, benda tu kita dah kaji awal-awal ke? Macam natural disaster untuk buat bridge tu.
Okay, terima kasih.
Itu soalan saya.
Okay, satu je. Hello, adik. Okay, let me respond to that question. Okay, berkenaan dengan disaster load ni, saya pernah tanya dulu saya punya pakar coastal lah. Kalau sekarang dia dah besar lah, PM Faridah Jaafar Siddiq, pasal berkenaan cost. Pasal ni lah, pasal bencana load yang macam ni lah, macam tsunami kita kata tadi. Tsunami ni saya pernah tanya benda ni dulu. Dia kata dia ni dah pakar coastal. Dia cakap dalam code of practice tak ada pun cakap kita kena design untuk mencegah bencana yang disaster punya load ni. Tapi kita adalah macam extreme punya condition, extreme load by applying the load factor. Okay, dia kata kalau let's say kata you ada bridge kat sana. Okay, you tak boleh design let's say tanpa ada sebarang supporting document. Walaupun kita tahu tempat tu ada risk untuk ada tsunami. Tapi you can avoid that problem by shifting your alignment away from that risky area. Kita sebagai manusia ni kita tak boleh nak lawan dengan benda-benda macam ni. Kalau kita boleh ada solution, kita ada information bahawa tempat tu risky, try to avoid. Okay. Macam contoh saya ada satu dekat Sabah, ada satu proposal alignment Pen Borneo lah. Ni projek ni tengah under construction. Kita ada geotechnical engineer kata situ dia tends untuk collapse. Okay. Jadi kita kata kalau collapse kita buatlah ground treatment. Pasang geotextile ke, buat soil nailing dekat slope. Tapi dia kata cost tu tak teramat besar. Dia kata kalau tak buat bahaya pula. Tapi lepas tu dia kata macam mana? Kalau kita nak main dekat structure tu, itself design untuk benda-benda yang tanah yang lemah ni, maknanya ada potensi nak runtuh ke. Earthquake pun besar kat situ saya tengok tu. Dia punya 0.1G. Jadi saya kata sebab ni since tanah ni tanah hutan, tanah forest area, saya minta dia buat zoning kat mana yang risky area, yang mana yang tempat yang safe area, yang tak berapa risk area, dan kita minta daripada situ kita study alignment kita boleh shift, tukar je. Sebab kalau you nak design structure untuk betul-betul 100% boleh withstand this tsunami, maknanya earthquake more than 8 scale factor, benda tu pun belum guarantee dalam code effective pun tak ada cakap dalam code effective saya tak pernah jumpa kata dia boleh menahan tsunami atau earthquake yang lebih pada 8. Kalau boleh kita as engineer kita kena proaktif sikit, cuba communicate dengan other field solution dia, dan kita at the end kita buat decision sama ada kita nak away daripada problem tu. Kalau boleh elak, jangan nak pergi kat situ. Jangan buat kita punya alignment bridge kita kat kawasan tu. Okay. Itu adalah pandangan saya lah. Okay, adakah menjawab soalan tu? Siapa tadi? Fatin?
Ya, menjawab. Terima kasih.
Sebab macam yang second bridge tu, dulu dia ada alignment original asal dia the straight. Dia asal saya ingat lagi sebab masa tu saya punya ex-boss saya dia buat master plan untuk second plan. Lepas tu tiba-tiba orang highway, orang bahagian trafik kata kalau straight ni mengantuk sangat. Dia kata kalau panjang dengan 16 masa tu 13 km lebih kurang sama dengan yang existing ni dulu. Dia kata why not kita try bend sikit bridge kita ni, bengkok sikit. Itu adalah salah satulah caranya dia nak buat the problem. Dia kata takut driver dia mengantuk kalau bawa long distance straight je, kita bawa dia jalan tu bengkok sikit. At least dia ada satu consciousness dia tu meningkat. Dia punya awareness dia tu akan meningkat bila dia pusing steering nak ambil the curve alignment tu. Itu adalah salah satu contoh lah kita nak avoid the problem. Okay, Cik Fatin. Hello.
Okay, terima kasih.
Okay, thank you. Anything else? Anybody else to ask? Ada satu soalan sini. Alright, Ikram ada the main from the chat rooms lah. From the chat room ada satu soalan kat sini. Saya baca.
Okay.
I would like to ask how the bridge handle vibration when it is cool, hot or rainy. Is the vibrations on the bridge would all be the same for all situation, and how the bridge handle for each weather? That is question. Actually, they are asking about effect of weather on vibration, I think.
Okay, actually the vibration level magnitude for the different temperature, different punya reading. Actually, usually to overcome this problem, to handle this problem, usually one of the way to address the problem, usually we try to stiffen the bridge itself. Okay, in other words, we try to increase the stiffness, the geometry of the bridge. Okay, by as I mentioned just now, maybe we try to put the dummy material. Okay, by having the pavement material. Okay, this is the one example that we did last time. Okay, we because there is the overlay on the bridge deck. Usually we use the 50 mm 2 inch only. Okay, to absorb. Okay, you know this flexible pavement. I mean the overlay is can play the role to absorb the vibration from the vehicle. I mean from the tire, from the moving loop. So usually there is the allocation. I mean there's the allocation. I mean the allocation. Okay, usually from the road department in JKR. Okay, to increase the thickness over the years. Okay, the maximum usually for this additional thickness is 110 mm. Okay, we can increase the thickness of this overlay pavement. Okay, to reduce the vibration. In other words, let's say for the raining time. Okay, the raining season. When this is the problem when it comes to the raining time. Okay, especially for the expression joint. Usually the expression this component actually the purpose of expression joint actually want to accommodate to provide to allow the bridge to span, to elongate, to shrink, and then to expand due to the hot and cold weather. Okay, however, this device expression joint also can actually contribute to the vibration issue. Okay, because so to reduce this vibration due to this expression joint. Okay, because when the car hit on this pavement, this expression actually they also trigger this car also vibrate and then transfer this vibration from the vehicle to the bridge. Not also, and then there's a report. Actually, this expression also contribute the vibration to the bridge. So, in order to control the vibration, actually, we can eliminate the usage of the expression joint. Okay, by introducing the semi-integral structure. You still have the bearing, but we just omit the usage of the expression joint because expression it was confirmed that can contribute the vibration of the bridge, especially at the raining season. Okay, that's all. Okay, any answer to your question?
Pertanyaan ni Siti Fatimah.
So in other words, nowadays in a bridge design, so they are avoid to using the expression joint. Am I right?
Yeah, because expression actually is a maintenance cost for the JKR, for the client also, for the project owner. Especially JKR, they do not favor to adopt for the expression joint. Yeah, for the during my time last time, this JKR said for the less than 30 meter and lesser than 30 meter, automatically go to the fully integral. Don't use the simply support bearing and expression joint. They want to reduce the maintenance cost. Okay, I still remember that.
So in fact, recently I got to know that this event, just if I'm not mistaken, last month. So they have a falling of expansion joint in first bridge in Penang. Got the news?
Not sure lah, but I heard that news from my friend. Oh,
okay. Okay, so I have one question. Okay. Okay, may I know, okay, what is a common practice to improve the stiffness in the bridge? Okay, so in order to cater the vibration effect, the common practice.
This after construction or before construction?
For instance, that before and okay, they have a two condition. Okay, for a new structure and before we construct in the design stage. Okay, another one for the existing structure. So how? Okay, based on two conditions, how we improve the stiffness? Because improve resistance, as you're told that principally, so it will increase the frequency of the bridge.
Also, increase the cost, increase the weight of the structure itself, the structure.
Okay, so
Okay,
how?
for the new bridge, in the planning stage, usually we, as I told, we as a designer, we need to carry out the dynamic test, dynamic analysis. Okay, second order analysis. We have to perform that so that it will, this our concept, our approach, can need to certify the minimum frequency that was stated by the cooperative. Like I said, in BS and both EC2 and BS, both code agree to put the 5 Hz frequency minimum is recommended to be certified by the bridge design. Okay, and then for the existing one, okay, what I so far in Malaysia, I do not see the way they mitigate this problem to control the vibration. But but in Euro, usually they will install the TMDTU mesh damper, the mechanical device, okay, at the bottom of the beam, the girder. Okay, that's the way. But in the bridge, in the Malaysia, based on the MR2 that I shared just now, until now there's no any mechanical device or any the mitigation action has been taken to overcome this problem. I don't know. That one I don't want to comment further because this is about the policy interest of the client. So I don't want to comment further about this.
Maybe in our culture is we waiting for a bridge to collapse, then
that one I don't know.
Creation.
I don't want to say. That's cakap kampung macam tu lah. Tunggu seorang meninggal dulu barulah nak fikir. Tu lah. Tapi dekat overseas, I pernah jumpa dekat Korea. Last time I visit there. Okay, dia memang dia concern about the, kalau you, yalah, di Korea ni lain sikit lah, tak macam. Yalah, dia kalau kita naik dia punya subway dia tu, dia punya vibration tu memang ni, dia punya subway dia tu beberapa layer dia tu. You boleh telefon you ni, handset you ni boleh still lagi dapat connection. Walau tanah, padahal tu bawah berapa layer, dia bertingkat bawah tanah. Tapi kita kalau kita masuk dekat menara tanah dah hilang dah radio punya frekuensi kan.
Jangan kata dekat menara tanah, dekat dalam lift pun dah hilang.
Ya, that's true. Tu yang I wonder, terkejut. Padahal hari ni dah tahu berapa layer lah tanah tu. Masih dapat lagi signal, boleh main WhatsApp, boleh tengok apa ni, FB semua. Lepas tu dia punya vibration memang, dia punya noise tu memang senyap lah, memang absorb betul. Jadi kalau kita boleh dapat sampai level tu bagus lah. Tapi insya-Allah dapat kat Malaysia. Okey. Dr. Asyari.
Okey.
Ada lagi tak soalan? Open for the last lah kot. If we still have a question, I give a last, open for the last question lah kot. Tak ada lah kot.
So if not, before we end the meeting, maybe we can.
How is
Yeah. We have a photo session. Can we make a photo session before we end the session? Dr. Wan? Oh, Dr. Wan. Freeze. Hello?
Hello?
Tadi ke internet.
Internet saya pun dah macam putus.
Okay.
I lost.
Maybe we can make a photo session before we end the meeting.
Yeah.
Okay, so
everybody can please turn on your camera, student. So all students, please turn on your camera. Then sisi gambar sekejap.
Tingkat berapa dah atas hari? Tingkat berapa tu
atas sekali?
Atas kat sisi.
Kami semua duduk atas. Kami semua duduk kat atas.
Ya.
Satu level.
Nampak lah semua gambar
Okay.
Okay, everybody, please turn on your camera. Okay, bolehlah kot. Now.
Syahari tolong ambil sama ni. Ni takut saya macam slow, dia tak boleh nak ni. Tak appear.
Okay. So I'll capture the picture. Okay. Okay, so how? I'm done it. Okay, so Dr. Wan, can you conclude the session?
Okay, thank you everyone for your participation. Student, don't forget your attendance in your future. Please take those who still not do that previously. So, and again, to our speakers, IR Wan Ikram, which is from UTM, thank you very much for your sharing session, and hopefully all students can get a good information regarding to the talk event. And sampai kat sini lah kot. Terima kasih untuk semua. Again.
Okay, terima kasih Dr. Wan. Terima kasih Dr. Syahri.
Okay, thank you, IR Wan Ikram. So thank you for your impressive presentation. Okay,
not really impressive. And knowledge sharing Dr. Syahri.
Informative information in terms of practicing in. Okay. So see you. Assalamualaikum.
Assalamualaikum semua.
Assalamualaikum Doktor.